Next up, we're working on section 3.5, which is about a method called variation of parameters. When we're talking about this method, what we're going to do is we're going to work through a second order derivation. And then we're going to kind of regroup and we're going to talk about the steps we use to solve a second order equation using this method, because I know that derivations can kind of be a little overwhelming. Then we'll work through some examples, and then we're going to expand our method to a third order equation, and that's the highest order we'll go to. So first off, what I'm going to do is we're just going to describe the type of method or type of problem this method applies to. Oops. So we're just going to talk about what is a variation of parameters problem. And this is going to be related to what we learned last section because it's a method for finding particular solutions. So we are looking for particular solutions. To this differential equation, y double prime plus some p of x times y prime plus q of x times y equal to f of x. And that's going to be a non-homogeneous second order equation. And so just for comparison, when we were learning the undetermined coefficient method, we were working with nth order differential equations, so we could go as high as we wanted, but only for constant coefficients. And here what we've got are non-constant coefficients. They can depend on the function x. They don't have to be just numbers. So you've kind of like gained flexibility in those coefficients. They can be functions of x now, but we've lost flexibility in the order. They can only go up to second order. That's the trade-off between these two different methods we talked about, or that we're currently talking about, I guess. The way that we're going to solve this is going to be hopefully getting kind of familiar by now. We're going to assume that we know what y sub p is. We're going to say, I think it's u1, y1 plus u2, y2. For y1, y2 solutions to y double prime plus py prime plus qy equal to 0, and u1, u2 unknown functions of x. And so the big takeaway here is that's the shape we think yp is. And with this method, like a lot of methods in class, we're just going to assume that's true, plug it into the differential equation, and see what u1 and u2 have to be in order for that to happen. So we need to plug y sub p into our ODE in order to solve for u1 and u2. And next up, what we're going to do is we're going to actually derive what u1 and u2 should be in the general case. And this is going to be one of those sections where after we do this derivation, I'm going to give you the formula for what u1 and u2 are. And the derivation is so long that I'm not even going to try to make you not use the formula. But we're still going to do the derivation because it's practicing this really important skill of assuming what y is, using some fancy calculus and algebra to determine what u should be. So just pay attention here, try to take everything in, but know that at the end of all this, I'm going to give you a formula and you're going to be able to like hold that in your hand to find u in the future. Just for now, try to engage with like the way that we solve this type of problem. Maybe don't even bother taking notes on this part. I'll tell you when to start taking notes again. So what we're doing is we're trying to derive u1 and u2. So if y sub p is equal to u1 y1 plus u2 y2, then do I have enough room? I think I have enough room. Y sub p prime is going to be u1 prime y1 plus y1 u1 prime plus u2 prime y2 plus u2 y2 prime. That's just using the product rule on what I assumed yp was, knowing that u1 and u2 are unknown functions of x, so they need their derivatives counted, and y1, y2 are known solutions to a differential equation, so they're probably functions of x as well, so I need to count their derivatives. Here, I wrote the wrong thing, u1, y1 prime. There we go. And then yp double prime, which I need in order to plug into my differential equation, is going to be a lot longer. It's going to be u1 double prime y1 plus 2 of these middle derivatives. This middle derivative thing should be familiar to you from when we did reduction of order. And then u1 y1 double prime. Same pattern for our u2 and y2. And again, this is just the product rule applied to several terms. So we haven't done anything really extreme yet. But what we want is for this to satisfy our differential equation. So this should have u1, u2 that satisfy the ODE. So what we're going to want to have is that f was equal to, we want yp double prime plus p times yp prime plus q times yp. And I'm going to plug in my functions and see what happens. So yp double prime was very long, u1 double prime y1 plus 2u1 prime y1 prime plus u1 y1 double prime plus u2 double prime y2 prime y2 prime plus u2 y2 double prime. I'll do an arrow there. That was yp double prime, just taken from right up there. Sometimes I wish I had some kind of like lasso tool where I could grab an equation and then drag it down. Then p times yp prime was u1 prime y1 plus u1 y1 prime plus u2 prime y2 plus u2 y2 prime. Then plus q times y sub p, q times u1 y1 plus u2 y2. All I did just now was take those derivatives we calculated and plug them into the differential equation, because the entire reason we took those derivatives was to try and satisfy the differential equation. My goal is to try and find what u1 and u2 are. This is a whole big mess that I couldn't possibly think about using to solve for u1 and u2, mostly because there are derivatives of u1 and u2. So all I've done is turn this into a more complicated differential equation. What I'm going to do is I'm going to try to simplify things as best I can. And the way to do that is going to be that I'm going to pull out my things that are related to u1. Let's do like a squiggly line for those things. So here's a term attached to u1. Here's a term attached to u1. And here's a term attached to u1. So what I just found was y1 double prime times u1 plus pu1 times y1 prime plus q times y1 times py1 prime plus q times y1. And I'm going to do the same thing with u2. So I've got u2 times y2 double prime right there, times y2 prime right there, times y2 right there. Oops, and I better indicate where I'm putting that. So I'm going to have u2 times y2 double prime plus p times u2 times y2 prime plus q times u2 times y2. So I've represented all those terms together. And then I'm going to go ahead and write all my leftovers right here. So what's left is u1 double prime y1 plus 2u1 prime y1 prime plus u2 double prime y2 plus 2u2 prime y2 prime plus p times u1 prime y1 plus u2 prime y2. Okay, in the next video, we're going to continue with simplifying this and trying to solve for u1, u2.